Okay, so we are going to be practicing the same thing, but now we actually know when to stop. So the first thing that is, I guess I should emphasize, is that a problem might seem really, really complicated. Well, if we can make that problem into a simpler equation, then we should. We should be trying to manipulate equations. And it's all good critical thinking skills, and I guess just getting you to understand that manipulating equations sometimes is the best way to go. So in this problem, they just want to verify first that both sides of the equation are equal to the same value for theta, in this case pi over 6. So as we look at this, this problem is really the same as 1 over cosine of pi over 6. It might help some of you. Minus cosine of pi over 6. So if we were to look on the unit circle, pi over 6, this piece over here is that ordered pair root 3 over 2 comma 1/2, which you should have memorized. So remember, secant's a reciprocal of that cosine, so 2 over root 3 minus cosine would be that root 3 over 2. And if you did a little, you could do the butterfly method I talked about before, where you do 2 times 2 is 4, and minus root 3 times root 3 would be 3, all over 2 root 3, and I don't care if you leave it like that, or if you rationalize that denominator, which would be root 3 over 2 times 3 is 6. Okay, so that's just working with the left side. Well, if you do the right side, and do that in a different color, the sine coordinate of that would be 1/2. Tangent, by definition, is sine over cosine, so that would be 1/2 over root 3 over 2. I should be showing steps, but I'm not. I'm sorry for that. And I've shown you tricks before where you could divide by the same denominator and they'll cancel each other out. If you don't believe me, then you can practice. I write it off to the side here. That 1/2 is still there. I'm not messing with that yet. You'd have 1/2 times divided by a fraction is multiplied by the reciprocal, and you can actually see those 2's cancel out. And you're left with 1 over 2 root 3, which is the same as this, which is obviously the same as this then. So this equation is true for pi over 6. The issue that we have is that is not all values of theta. Not all values. So that's where we get into this goal of rewriting one side at a time until you get the other. And if at some point you get stuck, you can go to the right side and then rewrite it as the left sides. So there's definitely a set procedure to go here, but now I'm telling you when to stop. And the typical advice that teachers give is to start with a more complicated thing. Because if you start with the easier thing, you might not know, or you might not see the light at the end of the tunnel on what to do to change it. So we actually have the same equation here on the left side. Now we're actually practicing. So that's what I started to do. And notice I'm just starting with the left side. I'm not messing with that right side yet. And as I'm looking at that, I would rewrite, because I want the same denominator, so I would multiply the right side by cosine of theta. And you can't just stick a cosine into the denominator. You also have to multiply the cosine in the numerator, so it becomes cosine squared, right? Cosine times cosine. So in the numerator, I have 1 minus cosine squared, because the denominators are the same, it stays the same. So that is cosine of theta. Well, 1 minus cosine squared, I think we've done enough of those where you realize that that is sine squared of theta over cosine of theta. I should be putting equal signs in here like this. The left side is equal to that, which is equal to that, which is equal to this. Now, you might not see the light at the end of the tunnel yet, which obviously I know where I'm going with this. Like, I know to stop once I get to the right side. So what I would do is just split up that sign. So that's the same thing as saying sine times sine. And I'm going to strategically just slide that cosine to the right. Because now that I'm seeing this, okay, well, the sine piece, I highlight it, the sine is matching up. And then I have the sine over cosine. Oh, wait a minute. Sine over cosine is equal to tangent. So we are good. We have now shown it. That the left side manipulated over and over again is equal to sine times tangent. And depending on how good you are with unit circle, I shouldn't even put a box around it. The box would be the entire work. Because I'll be looking step by step on your homework, on your test. Clearly, you have the answer right there. Like, if you just put a box around an answer, and I've had students try this on me. They've tried to just say, or they just jump from this step to this one, and I'm like, no. You got to show me those steps. I'll be looking at your work. I'll be vigilantly looking at your work. Let me put it that way. So yeah. And you'll notice that I usually start with the left side. And the reason why I usually start with the left side is usually that's kind of the whole premise of these problems. So as I start with this next one, I'm just rewriting. I like sine and cosine. I don't like seeing cotangent, so I'm going to rewrite cotangent. Now, how about this? I'll just rewrite the problem so you know that I'm starting with the left side. So now let me rewrite what I was about to write. That's a multiplication, by the way. Sorry, my dots look like minus sometimes. So rewrite cotangent as cosine over sine. Well, as I look at that, I'm seeing that we have the sines would cancel. So I'm literally left with cosine over cosine. Well, that's exactly 1. All right. So do you see how sometimes you might end up at a roadblock? Which, by the way, I believe this is true, that they both equal 1. So talk about an identity here. Like, this statement's kind of worthless. So this is where I got stuck. So maybe I'll go to the right side. So I'm going to just go to the right side real quick. And then just rewrite the left side, the right side, secant. Rewrite that as 1 over cosine. Oh, well, we get into another situation where the cosines will cancel, and we're just left with 1. And so really that's where we can then just connect the dots to show that the left side, after doing step by step, we end up with the right side. And I know I've only shown you this a few times, but if you go to your calculator and you were to type in, oh, that is ugly, these things. Now remember, I don't have a secant button, so I would actually have to write out as a fraction 1 over cosine of x times cosine of x. And when I go to my graph, I'll actually get a horizontal line at y equals 1, because that's exactly what it equals. And if I did the other one, you would also see y equals 1, and they would fall on top of each other. So this is pretty much I would not simplify this left side to the right side. I would simplify the left side to equal 1, and then stop there. I wouldn't want anything else. But so that was probably a terrible example to show. But you're still getting the thought process down, that you only work with one side at a time. So if you look at this next example, to me, the left side, that looks complicated. So I would probably rewrite secant as 1 over cosine. By the way, I don't have to see you rewrite the left side. I just did it on the previous example because that's what some math books do. And we don't use a math book, so. Cotangent is cosine over sine. And instead of writing another cosine, I'm just going to make this cosine squared. Because cosine times cosine is cosine squared. But again, I'm only working with the left side. So now as I distribute this 1 over cosine in, I don't know if I even want to do that. Some of you can do that if you want to work through this on your own. I think what I would do, because I see the denominators are the same inside, probably work with that first. Because then I can combine those denominators to be the same. I'm looking at the numerator as 1 minus cosine squared, which I hope we've done enough examples so far that you have memorized then that 1 minus cosine squared is equal to sine squared. And the whole point of doing that is then you could recognize that the one of those signs will cancel, and you're left with sine over cosine, which is equal to tangent. So I just did 3 steps to get from the left side to the right side. And if you're thinking, well, Mr. Aby, you just said that you need to see every little step. I can clearly see from this step that you understood that 1 minus cosine squared equals sine squared. The issue I get in is some students might do this first step and then automatically jump to the right side. I don't think, and maybe I'm wrong, but I don't think you guys could jump from this first step to the final answer. And maybe I'm just being a stickler here, but there are some, if you're worried, show every little step. If you're worried that I'm going to take off points, show every little step. And that's kind of the nice thing of me as a teacher is I can dictate how many steps you need to show. Or if you disagree with me, you can bring it to my attention. Anyway, the next one. I'm starting with the left side. By the way, I don't like addition and subtraction. That's why I typically start with to me, those are more complicated than the multiplication. And if at any point you get lost, feel free to erase what you have and start over. So if you think the right side's more complicated, go for it. Work with that and see if you get the left side. So cosecant 1 over sine. I'm going to leave sine alone, except I'm going to put it over 1, because that'll help me recognize that the same denominator would be sine. I need to multiply the top by sine as well. Well, sine times sine is sine squared. So then that tells me that the denominator that's the same is sine. And again, I'm going to heed my own advice. I think it's pretty obvious that 1 minus sine squared is equal to cosine squared. To some of you, this might be obvious that equals that last answer, but for those that it's not as obvious, then go ahead and split up cosine. And slide that sine over, because you have cosine, and cosine over sine is cotangent. So you're noticing that I'm not circling any answer because the answer is already there. What I'm grading is your work that leads to that answer. And at any point you can pause the video. That is fine with me. It's your time. So as I move forward to the next one, again, I don't know what's more complicated to you guys, and I'm just trying to get this done before the video is over. So I'm going to just start with my butterfly method, where you do sine theta secant theta. This might be a terrible advice, and then my other butterfly would be this way. Cosine theta cosecant theta over cosecant theta secant theta. Okay, so that's just working with the left side. So as you simplify that, that would be sine over secant 1 over cosine plus cosine over sine, which my reciprocal of cosecant is sine, 1 over sine, I guess I should say. And then in the denominator, you'd have 1 over sine times cosine. I'm down to a minute, so I kind of have to hurry. So if I go too fast, please bring a question to class. So as I do my butterfly method again, I end up with sine squared plus cosine squared as you multiply the denominators there. Oh, I didn't need to do that. I'll just make a giant fraction there. Over sine times cosine. And then instead of dividing by that fraction, I'm going to multiply by the reciprocal. Whoops. So then each of these pieces will cancel. And I'm kind of at a loss because I have sine squared plus cosine squared, which tells me equals 1. And I'm going to guess that this right side equals 1, but I'll have to address it in the next video. So I'll see you then in a second.